Hello everyone, welcome back to my channel Execute Physics. Today we are going to deal with questions from the topic Momentum and Impulse from 2023 question paper. My first question is from paper 2. So what does the question state? You have the momentum of a body is changed by a force acting on it for a period of time. So which action increases the change in momentum? So it is the momentum is being changed by force acting on it over a period of time, and which action increases the change in momentum. So we know that in order to bring about a change in momentum, what we need to do is we need either the object should accelerate by bringing about a change in velocity, that acceleration should go higher. So this will go, how will this happen? This acceleration can go increase only by applying more force over a given period of time. So the correct answer is by doubling the force for a same time period. So the correct answer is option B. Next, the figure shows a the figure shows a boy throwing a ball at an object in a fair ground. The ball has a mass of 190 grams and travels horizontally with a constant speed of 6.9 meter per second. So what we need to note first is this is not an SI unit. We have to convert the mass into SI unit. So it is 190 divided by 1000, which will be 0.19 kilograms, and the speed is also given to you in SI unit. So let it be as such. So we need to find out the momentum now. It is direct substitution when the mass of the ball and the speed with which it is moving is given to you. So momentum is mass times velocity. So mass would be 0.19 multiplied by 6.9. That will give you 1.311 kg meter per second. So the correct answer is 1.3 kilogram meter per second in the SI units. So it is a 2-mark question. So this relation followed by the answer should be clearly mentioned in your answer sheet. So next question, B part of the same question. After hitting the object, the ball bounces back along the same path with a speed of 1.5 meter per second, and the object has a mass of 1.8 kilogram. Calculate the speed of the object. So which are the two objects that is colliding? The object and the stationary object and the ball are colliding. Okay, so we need to find out the speed of the object after it is being hit by the ball. We know that the total momentum before collision will always be equal to the total momentum after the collision. The momentum is always conserved as per the law of conservation of momentum. So before the collision, if we look, what is the total momentum? The ball, in the A part of the question, we know that the ball has a mass of around 0.19, and what was the speed with which it was moving? That particular speed, which was around 6.9, I believe. Yes, 6.9. So the momentum of the ball before the collision is 1.3. And what is the momentum of the object after the before the collision? It was stationary. So the velocity of the object is 0. But the mass is given to you as 1.8 kilogram, which is in the correct SI unit. So mass 1.8 multiplied by 0 will give you the momentum of the object before collision. The sum of both the momentum of the ball and momentum of the object together, the sum up will give you the momentum before the collision. That particular value should be equal to the momentum after collision. After collision, what is happening? The ball is bouncing back along the straight path with a different speed, which is 1.5. So the mass will remain the same. So the momentum before collision of the ball will be the same mass, 0.19 multiplied by 1.5. But here we need to take into consideration the direction also, because velocity and momentum is a vector quantity. So since it is bouncing back, we need to put a negative value to the velocity. So the velocity would be minus 1.5. That is 0.190 multiplied by minus 1.5. That is the momentum of the ball. Plus the momentum of the object after collision is, the mass would remain the same, which is 1.8 multiplied by the velocity or the speed, which we have to find out. So let's just give a any random letter. Let it be V itself. So the momentum, we represent it as V. So this is what it would look like after the final substitution. So we need to just do simple mathematics to find out the value of V. You will get it as 0.88 meter per second. If you go wrong with the calculation, just have a look into it and do it. Don't forget this negative sign, because the ball is bouncing back after the collision. Okay, so the answer is 0.88 meter per second, because it is a speed. Next question. It is again from paper 4. You have a balloon of mass 15 grams is glued to a straw. So this is a straw and this is the balloon, and the straw is threaded onto an horizontal string. This is the horizontal string onto which the straw is threaded. The balloon is filled with air and then the air is released. So it is filled with air and later on this is released. As the air leaves the balloon experiences a force. Okay. The balloon accelerates from rest until it reaches its constant speed. It then travels 0.67 meter in 0.18 seconds at this constant speed. So with the given distance and the time, you can easily find out what is the speed of the balloon after the air is being released, because we know that the speed is distance over time. It is 0.167 divided by the time 0.18 second. So anyway, but the mass of the balloon is given to be in grams. We need to convert it into SI units by dividing it by 1000. So dividing it by 1000, it would give you 0.015015 kilogram. 15 kilogram. Now, first part of the question says explain in words what is meant by impulse. Impulse is actually it is a measure of the change in momentum upon the application of a force over a given period of time. That is a moving object which has got a particular momentum. The amount of force that is applied on that object over a period of time to bring about that change in momentum is called impulse, and it is a measure of force times the time taken. So it's a 1 mark question. Just a single statement would be more than enough. Impulse is force times the time taken or to bring about a change in momentum. Next question is calculate the resultant impulse on the balloon while it is accelerating. So we know that the initial velocity of the balloon is 0. It was stationary before the air is being released. So the initial velocity would be 0. And what is the final velocity? It is v, the distance over the time. So that would be around 3.72 meter per second. We know that impulse is the change in momentum. That is mv minus mvu. So we know the final velocity, we know the initial velocity, just substitute it and that will give you the impulse. The mass is already 0, it's already given to you. So the correct answer is 0.0558 Newton second, because it is force times the time taken. So SI unit of force is Newton and that of time is second. So Newton second you have to write. So that's about impulse. Now the third part of the question is explain how the momentum is conserved as the balloon is released. That is, initially when there was air within the balloon, what was the momentum, and after the air is being released, then it will have a particular momentum. How is it conserved? So we should understand that any moving objects will have momentum. So once before the air was being released, what was moving? The air molecules within the balloon was moving. So the momentum with which it was moving should be equal to the momentum after which it moves when it is released. So we have to conclude that the total momentum is conserved as the total momentum of air inside the balloon before it is being released is same as the momentum with which air is released, which moves in the opposite direction to the direction of motion of the balloon. It is a 2 mark question. So it has to be clearly mentioned that the total momentum of air inside the balloon, air was moving, air particles which is moving inside the balloon before it being released is same as the air with which it moves out in the opposite direction to the direction of motion of the balloon. So next question. The figure shows the direction of two forces acting on a different balloon as it moves. So these are the two forces that is acting on another balloon as it moves. So you can see a vertical force and a horizontal force. Determine the magnitude and direction of the resultant force on the balloon. So to calculate the resultant force, there are two methods. The first one is using diagrams, the parallelogram method, and the second one using Pythagoras theorem. So we'll discuss both the methods. First, we'll start with the parallelogram method. So what does a parallelogram method do? For that, look at the figure. It is clearly mentioned not to scale. So we just cannot trust the length of this horizontal and vertical line. So we'll do the scaling and draw. Okay. So I'll do the scaling. 0.5 centimeter on my ruler will represent 0.1 Newton. For ease of representation, you can also do 1 centimeter on your ruler represents 0.1 Newton. Okay, you can do like that also. So 0.5 Newton in my calculation is 0.5 centimeters, which is representing 0.1 Newton. So let's first take the vertical force. So vertical force, it is a force which is a vector quantity, so you should put an arrow as you draw the scale diagram. So 3.7 centimeters on my ruler will represent 0.74 Newton as per the scaling that I have taken. And the vertical force 0.4 Newton is represented by 2 centimeter on my ruler. The next step, after you have done the scaling and the given forces has been correctly drawn of correct length, the next step is to draw parallel lines to the vertical and the horizontal force. So to the horizontal force, I've drawn a parallel line. We have to create a parallelogram, and for the vertical force also we have to draw a parallel line, and we have to join these 2 points together. That would be the result, and this point and this point. So as you join together, you have to measure the length between this point and this point. That would give you the magnitude of the resultant force. So the length gives us the length of the resultant force is 4.3 centimeters, that is 0.84 Newton as per my scaling. So the magnitude of the resultant force is 0.84 Newton. Now they have also asked for the direction. So with reference to the horizontal force, let's take that we have to use a protractor to measure the angle. So the angle that I get is around 62 degrees. So the magnitude is around 0.84 Newton, and the direction relative to the horizontal force is 62 degrees. This is the resultant force method of calculating the resultant force using parallelogram method. We have to draw a diagram parallelogram using suitable scaling. Okay. The next is Pythagoras theorem. Using Pythagoras theorem is an alternative method. For that, you need to use a Pythagoras theorem to find out the resultant force. So we know that as you draw the line joining the two forces, you apply the Pythagoras theorem, and you will get the answer as that is the square root of 0.74 Newton square plus 0.4 square. The square root of both will give you the magnitude as 0.84 Newton. And for the angle with the horizontal, you need to use tan inverse of b by a, that is 0.74 by 0.4 tan inverse of that will give you 61.6 degrees, which is approximately the same. So this is a 10-mark question. You can use either one of the two methods. So it is a 4-mark question. So the calculation should be clearly mentioned. Even if you are doing the parallelogram method or the Pythagoras theorem, the calculation has to be clearly mentioned. And if you are using the parallelogram method, please make sure to mention the scale. This is a very important factor. Okay, I hope you have understood these questions that we discussed from 2023 question. If you have any doubts, please feel free to put your doubts on the comment section below. And thank you so much. Feel free to like, share, and subscribe. Thank you. Bye.